So I said that how I asked the question, how does a computer know if the machine it needs to talk to is local or remote? Another way, how does a computer identify what part of an IP address is network ID and what part is a host ID? He go to a process known as ending, right? And the ending is the computer takes its decimal value of IP addresses, convert it to a binary number, then he takes his subnet mask, all right, which is 255.255.0, convert it to a binary number. Do you guys see that 255 is all ones, all ones, all ones, and 00? Then he does a process known as ending. So ending, what is ending? Ending is logic Boolean math. What it said in pretty simple. It says that and then one and one is one. This is not really plus, all right? Well, some people look at it as plus, but you're not doing addition really. It's ending. And all other, the result, when you end one of one, you equal one, but all the result of the others is all possibilities and always zero for you. Zero and one is always zero. Zero and zero is always zero, and one and zero. This is if I have to explain this process, I want you to imagine you have a light bulb that uses two wires and is connected to each wire is connected to a switch. And the question we're trying to answer is when the light is on. When the light is on. Again, the light is on only if both switches and both wires are on. If you go for this, let's pretend this is a positive and this is the negative. And the only time when the light is on is when you turn both of them on. But if you turn one, if one is off and the other one is on, light bulb is off. If both of them are off, obviously it's off. If the one is on and the other one on it off, that's what the ending. But forget the math and forget everything. The only thing I want you to remember, just remember this rule. It said the only time when you're doing the ending process that the result is equal one, it's when both of them are equal one. So what the computer is going to do after converting this, he's going to go one and he's going to go to the process one and one equal one, one and one equal one, and he keep going to this process. He keep going to this process. I'm sorry, here and here. He keep going to this process till he get this result right here, right? If you can see, without me going further, the only time 1, 1, 1, so you could see 1, 1, 1 are equal ones, and the rest of them you have the 6 ones and 6 0. So obviously it's gonna result in all zeros, all right? And so as a result, 1 and 1, if you remember, 1 and 1 is 128 plus 64. If you remember the table that we used before, which is equal, which equal 192. And here the second octet equal 168, and the third octet equals 10, and the fourth octet 10 equals will be 0. So as a result, the computer now, after the ending process, he knows for sure that 192, 168, 10 is a network ID. And as a result, all computers in the same network have to have the same ID. Now, if the computer he needs to talk to another computer, and this computer right here, and its IP address, the other computer is 192.168.11.1. Now the computer will do the process of ending, and needless to tell you, the result will be different because there is 10 here, and there'll be 11 here. You may have 1 and 1 over here. So as a result, the computer comes to conclusion that the device, the other computer he needs to talk to, it is not local, it's remote. All right. So what is the ending process? The ending process is used by computer to identify if a computer they need to talk to is local or remote. If the result is the same, right? If the computer end his IP address with his own subnet mask, and the remote computer or the other computer IP address with his own subnet mask, and compare the result. If the results are identical, so the computer comes to conclusion that this machine is right here in my network. If the result of the ending is different, then he knows this is a remote computer, and as a result, need to forward this to a router, because a router would need to, this computer is remote, so as a result, this query need to be sent to a remote, to a router, and the router will do the same ending process till it finds the machines. All right. Often, IP addresses are classful, are divided, if you say, and often you ask the question, well, why did we use what do you call it? Why do you say 255 and you say sometimes it's slash what do you call it? Slash 24 slash 16? Where do we get this numbering that we do? Sometimes instead of me giving an IP address 192.168.1.0 and tell you, oh, the subnet mask is 255.255.255.0, I may do 192.168 that one that 0 slash 24. What I meant by slash 24 is, which is right here, I mean that 24-bit of the subnet mask, hence the word 24-bit of the subnet mask on a network ID. In other words, the first octet, the second octet, and the third octet are all part of the network ID. If only one octet is a network ID, then you can do 1.8. All right, if 2.16, and if it's more than 24, all right, there's one more over here. If instead of 24 is 25, then you turn another bit, and so far, and so far. Okay, so this is how we come. This is how we use this. How we come to these conclusions. All right, one of the most common questions we get every now and then, given a network ID. By the way, please, this is not an IP address. This is not an IP address. This is a network address. Network address. There's no one here. This is a class. This has 24, but the host has no number. There's no number have been assigned. So this is the network ID. This is the host ID, and no number has been assigned to this one. So as a result, when hosts are absent, we say that we have a network ID. Sometimes you may be given a network address such as this, and you'll be asked to find all the host IDs, all the host ID within this network, all possible host ID within this network. All right, and again, there is a mathematical procedure that we do to find that. And once we follow that by the way, we started from 0. Remember, we have how many bits we have here in this octet? We have 8 0. If you lined up all the 8 zeros and you go all the way down on the and you lined up and this is the lowest. If you have 8 zeros, the lowest value from 8 zeros is you turn all of them zeros. The highest value of all of them are all ones. So between all zeros and all ones, you're going to get the following. Here's what you're going to get. You're going to get the first host in the network. You're going to get the last host in the network. And then you're going to get something known as the broadcast. And by the way, in any network, you can't use all zeros. We can't use all zeros. And we can't use all one. The reason why? All zeros is it's that network, it's the network address, and all ones is a broadcast. So it is known whenever we calculate. I know in the future, I'll talk to you about an exception, but it is really common that whenever you were given a network like this, and you're asked to find all the possible host ID, we do something, we do to the power of n minus n. To the power of n minus n. In this case, to those minus 2, those 2, we are excluding all zeros and excluding all ones because all zeros and all ones has a purpose. Okay, we're gonna go over this process later on. And by the way, if you are taking, if you plan to take a CCNA certification, this is something that you need to do. Cisco will give you a network like this, and it tells you out of this, we need this number of hosts and we need this number of network. So how many bits will you borrow from here in order to create this network? This is, by the way, that's chapter 8. All right. We're visiting the concept again. Once you have a range of valid IP addresses, so each device in your network need to be given an IP address. But first, you have to do the calculations. Once you figure out the first and the last, you will exclude the first one and you exclude the last one, and you will use the second one and you use the last, and you use the the IP address before the last one. So you're going to sign all those, and you start signing them manually. I talked earlier and said there's 2 common ways for a computer to get an IP address. I said, one, we can assign it manually ourselves. This is manual user following. A second, we can also let a machine on our network that is known as a DHCP, which stands for Dynamic Host Configuration Protocol. It's right here. And the job of a DHCP is assigning IP addresses to all network devices. It is not it is not an easy thing for you to go to thousands of computers in your network and assign them an IP addresses. You'll be making tons of mistakes. So what we do, we outsource that job to a device known as a DHCP. And a DHCP stands for Dynamic Host Configuration Protocol. Now, we talked about this subject before, and in this we'll talk about how computer communicates in a network. And we say there are three ways. There's one known, a computer can talk to another computer using a unicast, computer to computer. Computer can talk to other computer using a broadcast, which is one computer to every computer in a network, or a computer to a selective group of computer, and this is known as a multicast. Say one to a selective. All right? When you look at IP addresses, you can safely divide IP addresses in what we call a private, public, and private. Public IP addresses are the type of IP addresses that are available and are used on the internet, for example. Any machine that is visible on the internet, it'll be using a public IP addresses. And this public IP addresses, you don't assign it yourself. No, you have to buy that IP address from what we call an ISP or your internet service provider. However, for inside your network, your LAN is known, or your home is known as a private. You can assign it whatever IP address you want. All right, as long as all machines in the network, in your network, in their home or office, have to have the same network. You can't give one computer 192.168.1.something, and another computer you give it 172.16.something. It does not work. So in other words, remember the rule that I said. For computers to talk to each other in the same network, they have to have the same network ID, and they have to have unique host ID. In the most common type of private IP addresses that we use today in our modern network, we use this. This is, by the way, this range of private IP addresses have been put aside, have been reserved, so we can use it inside our network and homes. All right, and the range is from 10.00.08 to 10.00 to 10.55.55, or 172 from 172.16.00, all right, or 172.16.00 to 172.31.55.55. Finally, you guys are familiar with this one. This is one that you see a lot, and this is one that we use a lot of times. 192.168.00, all right, to 192.168.55.55. This is known as NAT, or is known as PAT, and that's what your home router use. If you right now stop and go to your computer, your Windows, open up your command line and type ipconfig, you will see that you get this IP address 192.168.1.1. That's something, right? All right. Next, since we do have other special IP addresses that we do not assign, computer assign them automatically, right? We don't even use them. And those, because they have special use on them. So you would never ever assign a machine this IP addresses. For instance, 172.00, right? 172.00 or 172.0.0.1 is known as a loopback and they're used for testing. So as a result, you're not going to use, we can't use, as a matter of fact, if you go to your computer right now and try to assign it 127.0.0.1, you're going to get an error. Your computer tells you can't use this because this IP has a special use, which is testing the TCP/IP stack, or so as a result, you can use it. Another IP that is special and we don't use and a computer uses is known as 169.254. That's something. That has a name, special name, known as, commonly known as APIPA, which is Automatic Private IP Address. In other words, the way it works, when a computer in a network cannot find a DHCP, it assigns itself an IP address from this range over here that we call APIPA. All right, there's another one here that we don't use as often. All right, next thing you need to know about IPv4 IPv4 it's an IP address is 2 to the power of 32, and 2 to the power of 32 will give you a range of roughly 2 billion IP addresses. 2 billion IP addresses. Scientists and engineers have divided those 2 billion IP addresses into 4 categories. There's a Class A, Class B, Class C, and trust me, there's also Class D, and there's also Class E. However, the 3 most common one that we deal with is Class A, Class B, and Class C. And each one has a range, as you can see. Each class has a range. So IPv4 are divided into 5 classes: Class A, Class B, and Class C. All right, and each class has its own range. Okay. However, today as it is, we have depleted all the 2 billion of classful IP addresses, and we're using something known as a classless IP addresses. Classless IP addresses. Classless are type of IP addresses where we don't respect that /14, /8, or /16 or /24 anymore. You may get an IP address that gets probably 192.168.1.0/17. All right. So now you are defying, you're not respecting that classful boundaries anymore. When we don't respect them, we'll create, if you don't respect them, you're going to come out with something known as, what do you call it? Class. There's a classful, but when you don't respect them, you'll get something known as classless interdomain. And anytime you send IP address 192.168. something, then /27, not /24, you need to understand that IP address is not a classful IP address. It is a classless that is known as CIDRs, right? It's classless, known as classless interdomain routing IP addresses, all right? So we're done with IPv4 over here, and I'm going to move to IPv6 in a second.